Thank you very much for coming to this session. Simplicity, the one and only rule. Just a quick disclaimer though. This session is only 20 minutes and there is in no way I can cover everything I would love to cover. So my aim is to equip you with an idea of why simplicity is important and then some pointers to make some, quick wins in your quest to simplicity. But before that, it's a little bit about me. So I'm Juan, Spanish, been here for a long time now. Since 2007, I'm a developer for Opencast software. And I've been doing this for 11 years. I can say that I love my job, absolutely love it. So simplicity, Mr. Da Vinci, 500 years ago, he already had a good idea of the importance on simplicity. Simplicity is the ultimate sophistication, he said. I absolutely love this quote, and hopefully by the end of this talk, you'll agree with me. But before we even get there, I want to talk about, because I've noticed that people tend to interchange easy with simple. And I want to ask, is doing the simplest thing the same as doing the easiest thing? Because for me, I don't think it is. But whenever I am in a conundrum like this, I like to refer to the etymology of the word to try and see if I am fitting the word correctly into the right context. So let's just do that. Easy. In Spanish, my language, it's fácil, which comes from the Latin facilis, okay? Facilis in English means factible, okay? And the root of that word in Latin and Italian is facer, which means to do something, okay? So we can say that this easy means is something that's at hand, something that's reachable. It implies a familiarity, something that you are comfortable with. It's totally subjective as well. So, for what's easy for you, it might not be for me. For example, I don't know, for Cristiano Ronaldo, the way that he kicks the ball on free kicks, that curve that he gives to the ball. I love football and I like to play football. I can do that. I find it really hard to be able to do that. On the other hand, moving on to simple, if we go back again into Spanish, it's simple, which is exactly the same spelling as in English, but the Latin, it comes from simplex, and it's got two roots, which is sem and pel. Sem means one way, and pel means fold. So, one fold, one way, one face. That's kind of the idea. And then the opposite, which I find really interesting, is complexus, which has got a prefix, which is con. Con means with, okay? So if in Spanish you say con something, you mean with something. And then it's got a verb in there, which is plactere, which means to intertwine, okay? So if you marry those two words together with intertwines, that is what complex means, as opposed to simple, which is just one face, one fold. So we can say that simple is objective as well. Unlike easy, it is factual, it's based on a concrete fact. So then, is doing the simplest thing the same as doing the easiest thing? No, we can safely say that it's not. There are things that are simple but not easy. For example, I'm a father. Raising a child is simple, but it's definitely not easy. Or writing a book. The concept of writing a book is simple, but sitting down and writing a story that's compelling, that's engaging to the user, it's not easy. Likewise, there are things that are easy but not simple. A backend system, for example, for a developer that's been working in the same company for 20 years and he's been growing this backend system for 20 years. It's easy for him to work on it and iterate it and build top functionality on top of it. If I join that company tomorrow, I can guarantee you that it's not going to be easy for me. It's not simple. It's a complex system. There are things also that can be simple and easy. For example, bouncing a ball. Bouncing a ball. The idea of bouncing a ball, the concept is quite simple, quite simplistic, and likewise the execution. It's easy. So why is simplicity important? Before we get into that, though, we need to make clear that simplicity is a choice. Yeah, it does not happen as if by magic. It's something that you choose to do. For example, consider a startup. On their first release, code is going to be really quite simple. However, if simplicity is not pursued, then complexity is going to creep up exponentially. There is going to be a negative inertia that is going to drive exponential change for every single change you need to do in your application, as the sprints go by and the need for features increase. So you can say that your whole project is going to be dominated by complexity, but we can go even further. We can add an extra axis to this chart and say, okay, what's the cost for this? And I am quite comfortable in saying that if it doesn't correlate, it will be quite near to correlate with complexity, cost and complexity. And that is not a good place. That becomes the elephant in the room. Everybody knows about it and no one wants to talk about it. But yet features keep coming and sprints keep rolling. So it's like a big snowball that keeps growing and growing and growing and growing. We can swap this around though and say that if we achieve simplicity, then the rest quite simply doesn't matter. You will be able to do the greatest change with the least amount of effort. I am quite comfortable in saying that simplicity will rule over anything else. Simplicity owns anything else. It just doesn't matter. It doesn't matter if you are sprinting or you do Scrum or Kanban. It doesn't matter if you're doing waterfall. The bottom line is your application is so agile. What you're doing is so simplistic that you can just react to absolutely anything and build functionality on top of it with ease. You are making change simple, which is the ultimate goal for a developer. But let's look at this same problem from a different angle, okay? Consider the startup again. Let's go back to the first release, yeah? We've got inputs and outputs on whatever it is that deliver. Let's say that they deliver feature A, okay? So we've got some inputs and some outputs. Consider what's in between inputs and outputs, the code that you write, okay? So on your first release, code is gonna be really quite straightforward, greenfield project, everybody happy, cracking on with things, no pressure, excellent. Next sprint, you're going to be able to manage it as well. It's going to be good. But then pressure is going to start to build up. So on the third sprint, you start to feel it and you cut off corners. So it's no longer a straight line. You're adopting some complexity that you're aware of. You'll deal with it later, you're aware of. But for now, it'll do. But then sprints keep building up and complexity keep building up. And by the time you've done 6 sprints, the whole system is already really, really complex. And, consider a bug in your system or a new feature that you need to add. And it's right in the middle, like in the picture. What do you do? So what string do you pull? Is it A, B? Is it F? The bottom line is it doesn't matter. Whatever string you pull, you're going to end up in a knot. And if you undo that knot, you're going to end up in another knot straight away. This is time consuming, and that is why cost goes up. And that's why we end up with the elephant in the room. The complexity that we are generating is transpiring absolutely everywhere throughout your project, and it's owning completely everything and affecting completely everything. So how do we go about this then? How do we achieve simplicity? Well, first of all, and it's really important, this is not just about choosing, it's not about writing code. It's also about choosing the right tools for the job. I remember when I started 11 years ago, one of the senior developers, when I was working at AO.com, he said to me, I had only just created a pull request for something. And he said, well, Juan, I will do this differently because, this might be overcomplicating a little bit things. And he said, just because you can, it just doesn't mean you should. And that stayed with me all of the way until now. And it's going to stay with me forever because he's absolutely right. And I try to follow that always. And this applies to everything, architectural pattern. We've had numerous sessions today about microservices. Majority of cases, microservices might be the right answer, but it's your duty to sit down and make sure that it's the simplest solution to pick. Languages, I love Node. It's lightweight, it's fast, it's excellent. I love Jest. It's absolutely brilliant. But if I was faced with a new problem and a new greenfield project, it wouldn't be very professional to just default to Node. You need to sit down and think, what is the simplest thing to do, with the project that we've got at hand. Same applies to libraries. Oh, I've got this excellent library. It achieves what we need to do, does A, but it also does B, C, D, E, and F. Although we don't really care about this. We shouldn't do that. We need to sit down and think, what is the right thing for the project? What is the simplest thing? And really, for example, persistency, it's exactly the same, something really interesting. We've had, people keep talking about Mongo. Mongo seems to be the way forward these days. We just default to it. Or if you're in a CL, you default to Cosmos that wraps around Mongo. You're not really aware of the baggage that carries. It's your duty as a developer to understand that and to choose the simplest thing, because, I was 4 years old. I think it was 1989 when SQL Server was released. And so they've got 30 odd years behind them. So I think they know a thing or two about persistence and, how to optimize things and how to do the right thing. I'm not saying that Mongo is wrong. Absolutely not. But it's your duty to decide what is the simplest thing to do, okay? If it's already an already solved problem, then it's your duty to assess how it's been done to see if it's something that you need to adopt, or on the other hand, it's not something for you and you need to do something different. But you need to, at the very least, not default to something. You need to consider absolutely everything. That's your duty as a software developer. Going back to the etymology of simple, we talk about one fall, one phase, one way of doing things. By that, we don't mean one application or one service or 1/3 of one layer of persistence. I think we all know this. But by that, we mean single responsibilities, yeah? We all know this. Each module, class, function should do one thing and only one thing. And not only that, it should do it well. Yeah, that is so important. And that should be with us on every single line of code that we write. That is one of the roots of simplicity when writing code. It's not about going back to the startup. It's about reducing the intertwining as much as we possibly can. Having it always in your mind and being aware of it. We don't want to complex things. By complex, I mean, getting two things, A and B, and tie them together into a knot. We do not want to do that. We want something like this. Yeah, simplicity is a choice, and this is what our choice should be. Obviously, there is always going to be complexity, but we are going to assume that we are going to assume that complexity, and that is fine because we are assuming it, and we know that I've considered absolutely everything, and I am comfortable with this. That's absolutely fine. That's respectable. You can deal with it later, but we always need to make that choice. So if we step to a coding level, what are quick wins that we can do? First one, if-else statements. Okay, so let's just make it clear. So an if statement gets a single code path and it splits it into two. So if we go back to this picture, that's what an if statement does. Okay, so they add complexity. That's the bottom line. If statements with an else adds complexity. Now, this might sound really radical. I don't intend it to be that way. I am not saying do not use if-else statements. I am saying that if you have to use it, you need to be 100% sure that it is the simplest thing you have at hand. Generally, if-else statements tend to be all right in short scopes with a very small range of action. That's okay. But they tend to build a lot of complexity within bigger scope. The higher the abstraction, the more damage it does, because that if-else statement has got a greater range of action. So the effects are a lot more profound. Who hasn't seen, if-else statements at instantiation point of a class to decide what you should be? How do we deal with this kind of stuff? We've got polymorphism. Yeah, it's a difficult concept to understand. It's difficult to achieve, and sometimes it can lead to, code that you need to sit down and look at it. But it achieves simplicity because you are working with generic concepts. There's books. I've got this one here. I have it ready. this is an old book, but it's so relevant, so relevant. You've got pattern like strategy pattern that deals with this example that I just mentioned. So it's about being aware of it and thinking about each line of code that you write. State is another example. State adds complexity. That's a fact. Why? Because state needs time. Yeah? What was the value a second ago? What's the value going to be in 30 minutes? What's the value going to be in 45 minutes? And when you couple time with something, you need to manage it. Yeah? So you adding an extra dimension to a value. So let's say that you need to debug that, something with state. You need to set your application at that exact moment of time that the bug happened so that you understand what the state was. That is hard. Yeah? I'm sure everybody will agree with me, and everybody will have been there, 35 breakpoints. You have to do the loop 12 times and you get to the exact point in time, and then you start, okay, this is where I am, this is what happened. That is hard and time consuming. We don't want to do that. A bit of a lighter one, but I think it's something that that matters a lot. Lists. We tend to default to lists all the time. All the matters, yeah. Lists. If the data that you have in the list does not have to be ordered, why do you have it in a list? Because lists are a source of complexity, because each element in the sequence is coupled with the next. Yeah. Do you need to use a list? If not, there's other alternatives like a set avoids duplicates. Has anybody been in a situation where you need to filter a list to avoid duplicates? Sets are there for you, or it's about thinking and making the right steps. Again, programming paradigm, functional programming. I love it. Why? Because it's a lot easier to reason about, it's a lot easier to test, it's a lot easier to debug, because essentially what you're doing is composing, writing pure functions and then composing them together to achieve a goal, as opposed to an imperative kind of way of doing software development where you do things like, okay, I've got this, then I set it to this, then I look 10 times over it, and I move it over here, and then I do this, and this. You are coupled to order. I am not saying go and use a functional language, but I'm saying, when you're writing code, do quick wins that give you a functional flavor in the current language you are using. These days, this is achievable with almost any language. I am saying practice it. If you've never done functional programming, do a cutter, do fist bus functionally, and then move on to Uncle Bob's code cutter and see if it builds up in you. But it's so important because you end up naturally with much more straightforward code. Data. We tend to build super complex models to wrap around data that goes through our systems. These models have a lot of complexity. Does anybody remember? Has anybody used Link to SQL in the .NET framework? The amount of complexity that added to your application. Treat data as data, transform only what you need to transform, and model only the absolute minimum thing that you need to model. That's where there is the real benefit. There is so many other things to talk about here, but I want to move on to, what is the best path to achieve this, to achieve simplicity? And for me, with a shadow of a doubt, is test-driven development. Why? Because we are working at an atomic unit of behavior, okay? When our scope is so small, like this big, then to apply simplicity to that and think and reason about simplicity is a lot more straightforward, And then we keep seeking the simplest implementation iteratively. We keep iterating this. I'm not saying don't follow the easiest path when you're doing test-driven development. Sometimes it's okay to do the easiest thing if you're stuck and you need to get the ball rolling. But in the back of your mind, as you iterate through those refactoring stages, you always need to have with you the simplest implementation possible. Okay. So just to finalize, simplicity is a choice, and you just need to make it. Thank you very much for listening.